dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Hello, hello, how are you, my friend? Okay, today in my video, I'm gonna show you another video on Mastercam tip, and in this short video, I will show you how we can create a beautiful chamfer on edges, laying on the stiff surface. Okay, chamfering is very simple. Mastercam provides us the chamfer toolpath and just input parameter and you get a beautiful chamfer toolpath. But that's the 2D chamfer. For 3D chamfer, how about 3D chamfer? Yeah, Mastercam also provide us the 3D chamfer. But if you ever work with this, you can see the 3D chamfer has some limits. I will show you what's the limits of the 3D chamfer toolpath. Okay, look it under the screen. I have the park here. Yes, it's a very common type of park. You can see we have a three hole here with counter bore. You can see it's the counter bore for the screw. Okay, screw head. And when you make this counter bore, you normally you will see the burr on the edge of the hole. So we need to remove the burr and we need a beautiful chamfer here. And our customer sure they want to get a good park, no burr, and good deburring. So if you work with the park, how you debur this jet? Okay, someone will think about a 3D chamfer. Okay, um, so I will show you when we use the 3D chamfer and what happened. I'm gonna click on the toolpath here and select contour. Yeah, 3D chamfer. Okay, and I'm select the edge. Thing, reverse this, and thing, revert it, thing, and so the next step where I'm gonna select the tool. For example, I'm gonna select the chamfer mill here. We get a 10mm chamfer, and then input some parameter. For example, I want to make a okay. We select the 3D chamfer here, and I want to make a 0.5mm air braking. Okay, and so the lead in and lead out. All right, the feed plane, the clearance. Okay, yes, and see what happened. Ting, 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 ting. Yo, man, that's not funny at all. You can see that. Yeah, pretty sure it will damage the park. Yeah. How about this hole? Yeah, it's better. It's look better. And I will do the verify for you to see what happened when we select the 3D chamfer. Oh, it will be a nightmare. Okay, look at this. This is the park, and this is the 3D chamfer. Ding 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 ding. Okay, look from this view. Oh man, what happened? Oh man, look at this. Oh my god, you can see. Do you like a chamfer like this? Yeah, it's look interesting, but I don't think your customer or you will like it. How about this hole? Okay, we move to this hole and see what happened. Wow, looks better, right? It's look pretty nice. Okay, you can see chamfer look pretty nice, and it's much better than this one. It's a really nightmare. Okay, you can see even this chamfer is look better, but you can see the the difference in this part of the edge. There is much more material removed than this area because of the style of the surface. You can see we have a cylinder intersect with a taper face here, surface here. So of course, because of the geometry of the tool, and slowly there will be much material here should be removed. Okay, and why? Because why we have the different like this and this? Because you can uh, take into account of you can see this is a steep surface. It's around 45 degree, and this is a shallow surface. You can see it's just around 15 or 20 degree. So this is the difference. If you apply a 3 chamfer on a steep surface, you will get something like this. Yeah, this is terrible. You don't want to get it. The 3D chamfer is work pretty well on the shallow surface like this, but on a steep surface, and the intersection curve is round, not a line. If it's straight like this, no problem. But it's uh, the intersection of a cylinder surface on a steep surface, you will get nightmare. Okay. So is there any other solution for this? Uh, Let me check. Okay. Instead of using a chamfer tool, we will try to use a ball and mill because the chamfer is support both the chamfer tool and the uh, the ball and mill tool. Okay, we keep the same uh, parameter. We we do a 0.5 millimeter chamfer. Okay, let's see if we have any different. And okay, verified again. Ten. Look at this. Bean. Bean. Yes, you can see the difference. Now it's the get better than the previous one, but we still have uh, some problem here. Yeah, the tool still engage a lot of material at the high side of the edge, so that's not good. Still not good, right? Even we change the tool, we use a different kind of tool, but this not much different. Okay, we need to find another solution. Someone will try to I will show you a trick. Okay, someone will try to make an edge like this and do a trick like this one. We will move rotate this curve like this. Yeah, for example, we'll make 2 degree. This just a trick, but I don't know what is good. But we don't know how much to adjust. Okay, thing reverted. Okay, let's try. If we see any different, ten. Okay, it's all about the trick. Thing and yeah, you can see the difference. Yeah, that's our trick, but it's not good because we don't know how much and uh, where to adjust, so this is not a good idea. Okay, we don't like to use this method. Okay, so you can see the 3D chamfer is work pretty well on the shallow surface like this surface, but on the steep surface and with the curve like this, you will not get a good result. So we need to find another solution. Okay, and this is the trick today. Alright, we will not use the 3D chamfer toolpath. Instead, I will use a 3D toolpath. Okay, a 3D surface toolpath. And my favorite toolpath is the flowline toolpath. Yes, this is very powerful, and I like this toolpath very much. I will show you how I do it. Okay. We're gonna go to the solid, and for example, I will make a constant fillet here. Click on this ad. Okay, and I will put 0.5 in. Ding. So we got the fillet edge here, and we will use the flowline toolpath to cut this, but not do the full surface. We just want to cut one pass at the center of the surface. Okay, I will show you how to do it. Ding. Then I'm gonna click on the flowline toolpath, and Mastercam will ask us to select the surface, the dry surfaces. Okay, and I activate the solid selection. Just activate the face selection and select this face. Ding. Click on the flowline button to check if the cutting direction is right or not. Yeah, if you see something like this is the right direction, and if you see something like this, yes, this is the wrong direction. Okay, change the direction by clicking on the cut direction button. Okay, and we click on the start button to change the direction of the tool. Okay, and then I select the 6mm bore and mill, and the surface parameter stock to reef is 0. Okay, and very important parameter, we need to check on the reef cut. If you check on this, Mastercam will make only one pass at the center of the surface. The resolution, if you want to know what this means, go to the half button here, go to the seed file definition, and check on the resolution. Where is it? Okay, click on this. Mastercam will tell you what that means. Okay, I just want to tell you, if you want to get a file, a smooth toolpath, you should make it this value small. For example, 5 to 10% of the tool diameter. Okay, and remember to check on this to make one pass cut. Okay, ding. And now we can see okay, we need to add the lead in direction. Okay, 90 degree, 2mm. Okay, ding. Yeah. Oh, wrong direction. Change the direction to minus 90. Okay, now that's what. And yeah, you can see now we have the lead in motion. And okay, we verified it. Ding, 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 ding. Wait a minute. Okay, go. You can see that now we had a better chamfer tool pad, right? It's look better now, but it's still not perfect, right? Because you can see we still have the different material here, then the material here, the tool remove much material here. Yeah, and this is the final trick. Okay, we need to make something perfect, and I will remove this fillet, the solid, and I will remove this. Yeah. Okay, instead of creating a constant fillet, we will make a variable fillet. Yeah, this allow us to create a fillet with different value of radius. Okay, for the I will make the constant fillet here and a variable fillet for you to see the difference. Okay, you can see this is the um, constant fillet, and you can see even we have the same fillet radius, but because of the surface, you can see we have a small area of fillet here, and we have a large uh, area of fillet here, even though they have the same radius. So our goal is to create variable a variable fillet that look the same size. Okay, let's look at the same on this area and this area. Okay, for this how I will show you. uh, I will select variable fillet and we select this edge. Okay, this is the common value, so you can see we see the difference. So now I want to remove sorry, I want to reduce the radius value here at this area to make this look constantly. So I'm gonna click on the dynamic button here, let you to select the position you want to change the fillet value. Okay, and just remember to click on the edge selection if you are working on a solid. If you don't activate this, you cannot select any edge here. Yes, you can see when I click, there's nothing happen. But when you activate this, you can select the edge. Okay, this is our edge before doing the fillets. It's hidden, but if you move the mouse to this area, it will display. We click on this, and now we can select. We move the mouse to select the position we want to modify the fillet radius. Okay, this is the biggest. This area is the most difference. So I'm gonna move the mouse to here. You see the center of the curve. Click on this. So now you can input the value for the radius at this area. This is 0.5 and I want to reduce this. I can input 0.25. Okay, when we finish, we press the escape button on the keyboard. Okay, and you can see that it's look constant. Yeah, look very cool, right? I will do a quick measurement. You can see I'm click on the dynamic measurement here and click on this face. You can see the radius here is around zero point 0.5. Yes, 0.5 millimeter. And when I click on this area, you can see the difference. Thing. Yeah, you can see that only 0.25 radius. The radius is only 0.25, but they look nearly the same. Yes, because of the surface shape. This surface and this surface and look like the same. Okay. Yeah, okay, that's it, the trick for today. And now I will select this surface. Eh, checking the flow line direction. We will change the cut direction to it. Yeah, if you can see something like this, we are doing right. Okay. Ting. Yeah. And I will do another one here with the constant radius fillet for you to see the difference. Yeah, you can see, you can compare the difference on this surface. On this side, I will select this constant radius fillet. Okay, check the flow line, change the direction. Okay, okay. Thing. Yeah. Okay, now delete this 3D chamfer. We just keep the flowline toolpath here. Okay, we'll verify this. Boom. Okay, on the right side is the variable fill list and go. Do, 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 do. And you can see that. Wow, it's beautiful, right? Very beautiful. And on the left side is the constant radius fillet. You will see the difference. And you can see that this is the difference. This is okay. To make it easy to see, um, if we want to change the chamfering size of uh, toolpath, we can change the stock to leave on right. If you make a bigger chamfer, you can input a negative value, for example, 0.5. Oh, sorry, 0.05 to make a 0.05 bigger. Remember to make a negative value so the tool will engage to the material. Okay. We generate a toolpath. Okay, okay. And then yeah, and you can see we have pretty good chamfer here. Now when you input a negative value, when the chamfer become larger, it's hard to see the difference between two methods. But when you use uh, a small value of stock to leaf, you can see the difference very uh, clear. Okay, that's not really the same, right? Okay, for example, point minus 0.2. Okay, and this one, yes, that's both beautiful, right? Yeah, they are both beautiful. Even this one is more beautiful. It's surprising me. Yeah, you can see, you can select the right one for you. But by the way, it's much better than a 3D chamfer, right? Yes, that's the trick for today. Thanks for watching, and I hope to see you in another video on Mastercam. Okay, goodbye for now.